Okay, well, welcome to the last presentation this afternoon. Um, well, as Ricard was mentioning, my name is Luis. Today I'm here on behalf of the Acros Consortium. Uh, in this presentation, I will be presenting a brief introduction on this Acros project and also on which are the plans that we have. For sure, it's ongoing discussions, but at least the preliminary ideas we have for integrating the OpenSlice and the TeraFlowSDN projects. Okay. First of all, I will, as I said, I will go for the overview on the Acros project, then this integration, and finally, I will try to summarize briefly the new features that we envision for the TeraFlow. Then, well, this is the brief description of the project and consortium. It is an SNS Stream A project. As you see, we are 12 partners in total. And well, in case you want additional information with respect to what I'm going to explain, you have here the webpage link, so you can check there the additional details. The scope of the project, well, for sure, for the B5G, the beyond 5G and 6G infrastructures, it's imposing the automation of many different industries worldwide and many infrastructures and so on. At the end, that means we need to improve the way we manage and automate the different services, the methods we use to manage the different components in the infrastructures and so on. The goal for the Acros project is to develop an end-to-end service and management platform for these next generation networks. Okay, for sure we are focused on improving the classical keywords, performance, adaptability, growth, energy efficiency, scalability, automation, and so on. But also we want to be ETSI-ZSM aligned, and in that regard, we are envisioning a system where we have a highly distributed domain level orchestrators that are managed by a cloud native multi-domain orchestrator. I will show you a figure in a moment, probably will help in understanding the idea. So we have we start from the 5G really cross-domain infrastructures where we have, for instance, radio domains, we have transport domains, we have core domains, and we need to manage the services that we deploy over there. For that, we have the cross-domain orchestrators, and then we might have different cross-domains infrastructures, like these ones, each of them managed by a specific cross-domain orchestrator. And then on top, we have the multi-domain service orchestrator that is in charge of managing these cross-domain orchestrators. Besides, we have a set of common services that provide extra features that are consumed by the different cross-domain and multi-domain orchestrators. Okay, I will jump now to the detailed view of this architecture. For that, well, it's essentially you see the cross-domain orchestrators, you see the multi-domain orchestrator, and also we have the common services block. You see that the architecture for this multi-domain and the cross-domain, it's based on the ZSM architecture and well, ZSM framework. We have telemetry collection. We have then orchestration. This is more or less well known. But then we have this layer for intelligence that provides some additional features in terms of processing the data that is ingested and also taking appropriate decisions, intelligent decisions at the end. All that needs to be flavored with security and trust for sure. That means the different components in the architecture needs to have means for managing security aspects. And then we can use the common services for things that are, at the different levels. So, for instance, if you want to train models, instead of doing it locally, you can upload this to one of these AI as a service blocks. So you can first store upload the local data in the different orchestrators towards a centralized storage as a service with the appropriate levels of security for sure, and then run the AI as a service methods for training machine learning models that then the orchestrators can download and consume and run locally. Okay, that will be an example for this for how to use these different components. The reason for having this intelligence block at the different levels is because there are some specific closed loop that you can run locally and are just related to a specific domain. But then there are other cases where you need to go across domains, and that's the source of the name for the project. And then when you have to go across domains, then you need this multi-domain orchestrator taking care of the intelligent aspects of these closed loops. Just briefly to put the things in context. So at the end, the motivation for the project is, to decouple the orchestration, to be proactive in terms of actuation, feature all the different network automation and management activities with artificial intelligence and analytics capacities, enable zero-touch operations, try to automate things like, for instance, when you need to expand to a new cross-domain your system, automate all the activities for deploying this new cross-domain, instantiating everything, making these cross-domain orchestrators to get access to the underlying infrastructure, and having everything integrated as if it was deployed at the very beginning. For sure, provide appropriate levels of resource and service management, and as I was mentioning before, provide levels of security and trust that are suitable for this platform. The mapping of the testbeds that the different partners in the project will contribute and how they relate, it's illustrated in this slide. As you see, we are planning to deploy at UBTech in Athens, in both the multi-domain service orchestrator and a cross-domain orchestrator. Then in Patras, we plan to deploy 3 edge domains with a cross-domain orchestrator. In Madrid, it's planned to deploy the common services that I was mentioning. And then here at CTTC in Barcelona, we will deploy another cross-domain orchestrator that will be focused, in this case, on a core domain. Okay, and the idea is that we will interconnect all these different testbeds and perform integrated experiments involving the different cross-domain and the multi-domain orchestrators. Well, this is a slide illustrating in a bit more technical way this testbed setup. Maybe I can skip this part. The interesting part here is this how we map this cross-domain and the multi-domain orchestrators to existing softwares, and also where TeraFlow fits. So the idea is that I was mentioning the cross-domain orchestrators, this ACDO acronym, will be realized by means of OpenSlice. Then the end-to-end orchestrator will be Maestro. Maestro it's an orchestrator that is being developed by UBTech, and if I'm not wrong, as I was told, they are planning also to open source it at some point. And finally, for the control of the different network segments, mainly front-end, back-end, and then the edge and the cloud devices, we are planning to use TeraFlow here. That's more or less the description on the Acros project. Now jumping to the second part on integration between OpenSlice and the TeraFlowSDN. Well, I will not go into the details for the architecture because I thank Christos for the previous presentation. You helped a bit in this presentation also. The only thing that I want to mention here is that one of the extensions we envision is that in OpenSlice we will have to implement some SDN client API service that enables to interact with the TeraFlowSDN. The main topics for this interaction will be in terms of collecting which is the underlying topology, because at the end, if you want to deploy services cross-domain and you need to traverse different transport networks, core networks, somehow you need to configure these networks. There is where TeraFlow fits in, and that way we can expose some additional services in the OpenSlice catalog that are devoted to configuring this transport network. For that, besides collecting the topology, we will have to configure services. For that, we are considering layer 2 and layer 3 VPNs, and also to configure transport network slices. So that will be the main interaction between the OpenSlice and TeraFlow. And besides, I was mentioning before that in Acros, we are focused also in security and trust. We will have a component, it's named as security and trust as a service, will be running as a common service, as I was mentioning. But this specific block will also be instantiable, will be able to instantiate at the level of the orchestrator or as a sidecar, let's say, for the orchestrators, both the cross-domain and the multi-domain orchestrators. In that regard, the idea of this security and trust instance will be to manage specifically security aspects like installation of access control list and different rules for permitting or blocking traffic at different points in the network. Just in brief, that will be the idea. Well, I left here the proposed architecture for this security and trust component. This is the big one. I mean, the one at the common services. When we instantiate this block as a sidecar for the orchestrators, then probably what will happen is that we will deploy just the relevant components of this architecture. I will not go into all the details for this architecture because it might take some time. The only thing that I want to highlight is that it's ZSM aligned in the sense that we have some data collector at one point that then forwards the events and the notifications, alarms, whatever information that it's ingested to a data processing engine that makes use of the analytics as a service and the AI as a service blocks to download, for instance, specific analytics algorithms or AI models. And then in this runtime for AI and for analytics, it will run the appropriate data processing. The results of this processing will be then forward to the decision engine that will take appropriate decisions on what to do with the incoming information. And it will instruct the orchestrator to run some specific workflows, implement some policies, and so on. And then this orchestrator, by means of the control block, will make use of some clients to interact with the different elements in the platform. Among others, for instance, the TeraFlowSDN client that will be used, for instance, to retrieve topologies, manage ACLs for services, configuring and deconfiguring static ACLs, and things like that. That will be the main pipeline. There is also some attestation service that we envision to use for validating that the devices in the infrastructure are secure. We will be periodically monitoring the devices to be sure that the whole architecture where we are deploying the services is secure enough. And that will also be managed inside this pipeline. Okay. I will skip the rest. The rest is just a matter of control and database and message brokering interactions that probably we can skip. Regarding the data models we plan to use for these extensions, we try to identify relevant IETF, standardized. Some of them are still in draft data models. So we plan to use this RFC for the network topologies, the 8345, This enables to expose the network topologies in an abstract manner. The 8466 that enables to issue layer 2 VPN service request. The 8299, it's essentially the same, but for layer 3 VPNs. Then we are envisioning to use the IETF draft for these network slices. It's a framework for network slice service request and so on. It's based also on IETF technologies and so on. So we'll use this for requesting the network slices. And finally, the 8519 for managing the access control list. This is for essentially for the security part. That will be at a high level, these interactions. Now jumping to the new features for TeraFlowSDN. Essentially, well, this is more or less what I was mentioning. We will have to extend the NBI component in TeraFlow for sure with the different data models that I was mentioning beforehand. That will imply also managing some extensions and review the actual support that the service component offers for these different types of services and so on. There is a missing block here. I forgot to add, because for the slice model, we will also have to manage and review the status of the slice component in TeraFlow. And finally, for supporting ACLs, we will need to manage the northbound interface, the service slice, and also the SBI, because we will have to interact with the devices to actually install the different access control list rules. And we also envision to provide some support for in-band network telemetry in P4. And in that regard, this will be, I think, an activity mainly led by UBTech in this case, probably. The idea is that we want to enable checking the state of the connections and gathering telemetry directly from the data plane and how the different packets flow through the network. Okay, so for instance, things like latency, jitter, and things like that, I guess. That will be that for my presentation. I don't know if you have any question. You have, I will be happy to answer.